Can you guys remind me what something like this, what's that look like? Like a function, a to the x, 2 to the x, 3 to the x, 18 to the x. They all have slight differences, but they all have the same basic shape. Can anyone make that shape for me? I love it. Kick ass. When you do like this, you're sort of inherently saying something about this axis. What's true about this axis for anything in that form? What's true about the x-axis? What's it doing back here?
Going to the left infinitely.
Sure, a lot of functions go to the left infinitely, but what's it doing as it goes to the left? Getting closer and closer to what?
Zero.
Good. So what's the x-axis? It's an asshole. No, it's an asymptote, right? You guys with me? That's a basic truth about the graph of this function that we must know. Just like we all know what a parabola looks like and the vertex and all that kind of stuff and the axis of symmetry. Hey, we all know what an exponential function looks like, and what's a huge aspect about this function is its asymptote. So what is the, I don't even tell you what a is. I'm not going to tell you what the hell that is. What is the range of this? What's the lowest possible output? Good, can't touch zero. Right? Are there any negative outputs? Are there any negative outputs? Yes? Where does the function go down here? Because that would be negative outputs, correct? Does the function ever get down here? You guys understand? So output is y, correct? So there are a ton of positive outputs. There are no negative outputs, correct? There's nowhere where the output is negative. What is the smallest it can get? It can get almost to what? Zero. And it goes up forever, correct? Okay, I love it. So if I have an unshifted exponential function, the range will be 0 to infinity because it's got an asymptote at 0. How are we doing so far? No? Are you guys okay? All right, again, so what's the domain of this? What axis am I looking at now for the domain? X-axis. Where in the x-axis does it have outputs? Is there anywhere in the x-axis that won't have an output? We'll have an output up here. Yes, if I just follow that far enough. We'll have an output down here. Yes, I just have to follow it long enough. Is there any x that won't lead to an output? No. So the domain is all real numbers. Right? I can put whatever I want to right there. So the domain is negative infinity to infinity because it will eventually get to these, and it eventually get to those. Okay, so domain is all the inputs that have outputs. We know this. So how do you determine the domain if I give you the graph of something, or if I give you a function that you know the graph of? You just think, all right, what x? This covers the whole x-axis. Does it cover the whole y-axis? Is every y somewhere on the graph? Is this y on the graph somewhere?
No.
I don't understand. So can it get through that x-axis?
No.
No. So is this y on the graph somewhere?
No.
Nope, it can't get down there. So that's why the range is 0 to infinity. The output can't be negative. Okay, and think about this. Okay. So if I have 2 to the x, there is nothing I can put in there that will make the output negative. If I put a positive value in, it's just going to get bigger, bigger positive, correct? 2 to the first is 2, 2 squared is 4, 2 cubed is 8. Is everybody with me? What happens if I put negative values in there? negative 1, 2 to the negative 2. What is 2 to the negative 1? What's the negative power do? Yes, it flips it, right? Negative power means flip. That's all a negative power ever means, right? 4-letter word starts with F, you can say in mixed company. Right? So it flips. So what's 2 to the negative 2? What's 2 squared? 4. So 2 to the negative 2 is 1/4. That's all a negative power does, is flips what the answer normally would be. So negative power just means flip. What is always on top? If I did 2 to the negative 10 billion, wouldn't that just be 1/2 to the 10 billion? Can I ever get to 0? What's the only way a fraction could be 0 is if the top is 0. What is the top always? Freaking 1. Am I getting really small though? 1 divided by 2 to the 10 billionth power. Is that a big number or a small number? Small number. 1 divided by a freaking huge as shit is going to be really tiny. So that's why it gets close to 0, but it never gets there. It never gets to negative. Okay. So the normal range for an exponential function, it's not been shifted anywhere, is going to be 0 to infinity, not including 0. So what if I do this? What kind of shift is that? Down how much? 3. So what does everything on the graph do? Everything on the graph goes down 3. Real quick, if I wanted it to be right 3, how would I change it so it was right 3? Where would the minus 3 have to be? With the x. We know this. We know this. No matter what function I am looking at, if there's something with the x, that affects left and right. So if I wanted it to move right 3, it'd have to look like that. That's with the x. X is left and right. It's going to move left to right. Here, is that with the x? No. So it just takes that down 3. So every point goes down 3. Everything about the graph goes down 3. Where would the asymptote be now? Where was it? 0. Where will it be now? Where? Y equal negative 3. So what's the range going to be now? That's not good enough for an answer, but it's good enough for right now. What's the range now? Negative 3 to infinity, not including negative 3. So if I know how shifts work, I know every damn thing. If I know how shifts work, and I know what the basic graph looks like, I know everything. Everything about it moves. Okay, so look at, which one was it again? Yeah, 4b. Real quick, if I move this left or right, does that change the range at all? If I just pick this up and move it over, does it change the range? No. So see that 2x minus 1 business on the power of 6? That doesn't do anything to the range. Where does the asymptote go for 4b? Yeah, it goes up 2. So what's the range going to be now for 4b? From 2 to infinity. So you just have to think, you know the asymptote starts at 0. So if I move the function up or down, that's going to change the range. Maybe, is that all right? So you have to know the basic look of exponential functions. They look like, from your perspective, let me think, they look like this, right? And this is important. This is huge. This is almost like a vertex and a parabola. It's a huge point. So the big thing about these are, where's the asymptote? Okay, maybe.
What does the 6 do?
Not a damn thing. It's just the base. So all it's going to do is 6 instead of 3 would mean it's going up faster, because 6 squared is bigger than 3 squared. So the base could be any number. That's why I just put an A here. It doesn't affect the shape of it directly. It just makes it go up faster or up slower or something, right? Now, what's the domain for any exponential function? What's the domain? All real numbers. Right? I could put any number I want to in the exponent. There's no number that I'm not allowed to use in the exponent. So the domain's all real numbers. I've moved it around. Does that change the domain? It's still all real numbers. Just because I move it doesn't change. It's all real numbers. Right? Okay, maybe?
On the range,
Say again?
the zero is going to be on the left side.
All right, so the normal range for something, in fact, let me make this a 6, because it doesn't matter. The normal range for something to the x is 0 to infinity. And we know this. We know there's an asymptote here. Right? And again, I really want you to understand. So if I have 6 to the x, right? What do I want to put a 0 in? What's 6 to the 0? Question. 1. What's 6 to the negative 1? 1/6. What's 6 to the negative 2? 1 over 36. What's 6 to the negative 3? 16, right? This is about I don't know, 0.2 something maybe, 0.3 roughly. This is 0.166. This is about 0.04 something. Do you see how the outputs are getting, well, it should be 0.03, Jeff. The outputs are getting smaller and smaller. Shit, maybe I've done that wrong. Is that 004? I don't know. You guys can divide these. The outputs are getting smaller and smaller and smaller, and they're just going to continue getting smaller. That is why this thing just keeps getting closer to 0. I keep cutting the outputs in 1/6, right? Every time I take a step, it gets 1/6 as big, 1/6 as big, 1/6 as big, 1/6 as big. It's going to get infinitely close to 0. That's what an asymptote means. So, if I lift this whole thing up to, every aspect about it goes up to. So this point will go up to, this point will go up to, this will go up to. So now it's going to be from 2 to infinity. That's going to be the range. Okay. So if you know where the asymptote is, which you must know, you just have to know where the asymptote is for this shape. If I add or subtract something, it's going to move the asymptote by that much. So if I had this,
I think I'm just having complications with is like, wouldn't it be on the right side?
well, what would be on the right side?
The answer for the asymptote will be on the right side
The right side.
because it's a y.
The right side of what?
Like instead of for the range, it would be infinity 0 because.
All right, so it's always small to big. So what is the lowest output that I see? Almost 0. Up to what? Infinity.
Okay,
Yeah. Okay. So if I had, for example,
I got it.
if I had this. Where will the asymptote be now? At y equals negative 8. So what will the range be now? Negative 8 to infinity. Kabam. Because I know it starts at 0. So the minute I move it up or down, that little line that my curve has to exist above moves, right? So it moved down 8, so now the range is negative 8 to infinity. What's the domain? Yeah, I can plug whatever number I want to up there. I can raise 11 to any power I want to. Okay, I like it. anything else. And that's a huge part of this class, is just increasing our understanding of what basic functions look like. We all know what x squared looks like, we all know what x cubed looks like, we all know what absolute value of x looks like, the square root of x, right? This is just another one. This is just another one. So now you gotta just add it. You know what it looks like, and you know an important thing about it. Is that cool? Is that right? Okay, and what I'm surprised about is, does no one have a question about 4a? You got a question about 4a? Yeah, okay. What'd you try to do? Did you try to do something, or are you just not really sure what the hell to do?
Convert it to exponential, but like,
Oh, that won't help.
yeah.
Oh, jeebus. Okay. Come here. Real quick, recall. How would you find the domain of this? What does the square root look like? Where does it start? 0, 0. And where does it go from there? Yeah. Right? Looks like half of a parabola where the bottom half fell out. Agree with me? How does that help me with this question? Well, what can a square root not handle? What kind of inputs can it not handle? Yeah, I want it to come out real, because when we're graphing shit, thankfully we're just sticking with real things. We're not going to pull a bunch of colors into our graphs, no. Okay, maybe. Okay, so what must be true about this number then? If it can't be negative, it has to be greater than or equal to 0, right? So that's how you do a domain. You say to yourself, what can't happen or what must happen? Well, the inside, whatever that number is, has to be at least 0. So you write that. You write it mathematically, and then you solve that. Finding any domain is that simple. Say to yourself in English what must happen or what can't happen, and then write what you just said in Mathish, right? So for example, again, so then x greater than equal, subtract 1 divided by 2, bam. Yeah. Okay, so real quick, if I had this bad boy, Jeff, really? What can't happen? So the bottom can't be 0. The bottom can't be 0. Solve, right? Every function I give you, if you can say in English what must happen or what can't happen, and then write that in Mathish, solve it, you're done. It's almost too nice to believe, but that's how it should work. The domain is all the numbers that work. If you can say what would make things freak out and write that mathematically, you should figure out what numbers make it work. Okay. So you're obviously x can't be 7. Okay, so looking at this thing, what does a logarithm look like? Oh shit. So a to the x looks like this. What does log look like? Yeah, we graphed it before we even knew what it was. So this asymptote becomes this, because I'm flipping everything around, yes? And then it looks like this. So what number can't I plug in, but I can get really close to it?
0.
I can get really close to 0, correct? I just can't plug 0 because there's an asymptote here, right? So what must be true about this then? Whatever that number is, it must be greater than 0. I can't put a number into a log that is not positive. So whatever number is in there has to be positive to work. So this kind of shows you logarithms are very similar to roots, but they are also at the same time not the same. But do you see how this is greater than or equal to 0 because square root of 0 is 0? Logs can't even handle 0, so they're strictly greater than 0, but it kind of looks like a square root if I kind of ignore this part. So they have a lot of similarities, but they're definitely not the same thing. So a gigantic part of this class is just expanding the graphs of functions that you know. The better you know the shape of it, the better you can answer questions like this. If I have that shape in my mind and I got a domain question, I'm like, oh shit, I can't use 0, I've got to, okay, so the whatever that is, got to be greater than 0. So when you solve this, get x is less than 5. Okay, maybe. So if I try to plug something bigger than 5, what happens? Let's try to plug 6 in, what happens? 5 minus 6, negative 1. A log can't do a negative number, so that checks. It makes sense. So it's got to be less than 5 for this to work.
Does the base matter?
Say again?
Does the base matter?
Base doesn't matter where shit. It just has to be a legal base. Right? You can't have a negative base. You can't have a base of... why would a base of 1 not make any sense? What is 1 to any power? 1. So there's no way to have that happen. 1 to what power is 7? No, 1 to any power is 1. So log base 1, we wouldn't even do it. Maybe. So generally, yes, it doesn't matter what the base is. Right? Okay. In fact, this answer would be the same no matter what I put there, as long as it was something legal. Okay. Yes.
You have to switch the sign when you subtract.
Well, I didn't really switch the sign, did I? So when I added x, I got 5 bigger than x, which means x smaller than 5. I just read it that way. Yeah.
It's a negative.
If I subtract 5 and divide by negative, then I flip the sign, and then you catch up to me. Cool. Okay. Does that make sense? So domain and range questions are easier if you kind of remember what the function looks like, right? So if I give you an exponential, the range normally starts at 0, goes to infinity. So now you just think, okay, if it moves, now I know what the range is. I just move that 0 correspondingly. What's the range of a logarithm? Is there any output that I can't get for a log? Yeah, it's negative. It's all real numbers. Negative infinity to infinity. I can get every output possible. Okay. Okay. Now, please understand. If that still doesn't make sense, just ask me a follow-up question. It's fine. Does any part of that still not quite make sense? Or do you want to do another example, or do you want to do something else? Yes?
How do you find the asymptotes again?
Say again?
How do you find the asymptotes again?
So for this, we kind of know where they are, and we just move them, right?
Yeah, then just find it again.
Or for like a rational function,
Yeah.
right? All right, let's do a quick fire thing. Yeah, sure. First off, what's the horizontal asymptote? What situation am I in? What are the possible situations? The top degree is, so what are the three? There's 3 situations. The top degree can be smaller than the bottom, the top degree can equal the bottom degree, or the top degree can be bigger than the bottom. That's obviously the only 3 things that could happen, right? You guys have to remember what each of those things mean. What situation am I in? Top degree is smaller. Right. Which means which piece is getting bigger faster, the top or the bottom? Bottom's getting quicker faster. I'm squaring the damn thing, right? Which means over time, I'm dividing by more and more and more and more. So if I divide by bigger, 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 my outputs get smaller, smaller, smaller. So we keep saying 1, but no. Right? So again, so is the top getting bigger in this sequence? Is the top getting bigger?
Yes.
Is the bottom getting bigger?
Yes.
Which one's getting bigger faster? The bottom. This is 0.1. This is 0.02. This is 0.003. This is 0.0004. What are the outputs getting closer and closer to? 0. So when the top degree is smaller than the bottom degree, let it make sense. If I make x really, really big, I'm going to have a number divided by a much bigger number. It's going to 0. So horizontal asymptote here is y equals 0. When is it going to be the ratio of the two coefficients? When the degrees are the same, 11. Because then they're kind of going lockstep with each other. Neither one is growing faster than the other one. They're sort of like agreeing with each other. How do I find the vertical asymptotes?
Bottom equals 0.
Yeah, so vertical asymptotes are walls that I've put on certain x values. How do I determine what x values I'm not allowed to use? Domain. And in this problem, what's going to tell me what x values I can't use? Numbers that make the bottom 0. Okay, I like it. So how do you factor this guy?
X minus A, X plus C.
Minus 8, x plus 5. No, wait, x plus 3.
Okay, so what are my two vertical asymptotes? 8 and -3. Cool. So there's going to be a line at 8, like a dotted line at 8. There's a wall there, and there's going to be a wall at 3. Or -3, sorry. Is that all right? All right, so no. What you got, Jeff? Oh yeah, let's do that. Sure. Yeah, I like it. Okay. So what is the horizontal asymptote? What situation am I in? The degrees are the same. So this is where it's the ratio of the two. When x gets really freaking big, x squared is way bigger than 9 times x. 9 times a billion is big, yes? A billion squared, 9 billion is nothing compared to a billion squared. Are you guys with me? So when x gets really big, these don't mean shit. So that's 1/3 there, right? Okay, maybe. So when the degrees are the same, they grow at about the same rate. So neither one overpowers the other one. Here, the bottom overpowers the top. That's why it goes to 0. Here they're going to go to some finite number, which in this case, 1/3. So now you would have at 1/3 an asymptote, right? What about vertical asymptotes? What do you have to do? Yeah, so factor the bottom. So if you take a 3 out, what do you get?
X squared plus 4.
Is this factorable? Hell no. Not using real numbers, correct? If it was x squared minus 4, you could factor that all in. If I think the answer here is x plus 2, I'm wrong, because I get a middle term, don't I? They have to be different signs to cancel the middle term. There is no real 0 of this. In fact, if you try to set it equal to 0 and solve it, don't you have to take the square root of a negative number? All right, so no real. So are there any vertical asymptotes? None. There's no vertical asymptote. I just don't have any walls like this. I just have a wall like this. And of course, everybody's favorite situation, right? Anytime we have to do long division, it's a situation we like the most. What situation would that be? What's the only situation we ever looked at? We looked at the bottom bigger degree, we looked at equal degrees, the top bigger degree, right? So if I had, let me do one that's a little funky. You got it. There you go. This should be freaky-delic. Ooh, I love it. You would like that, Jeff. Let me start with the vertical asymptotes. What do you do to get the vertical asymptotes? Yeah, look at the bottom. So I gotta try to factor it. What kind of thing is the bottom? It's cubes, right? So how do you factor the bottom here? X, 2, 2, 2. So 1x, 1, 2. 2 x's, 2 2's. Right. Kabam! That's beautiful. So if I have 3 of each, 1 of each, 2 of each. And then the only thing I'm missing then is the same sign here. So what sign is this going to be? Minus 2x. That's all it takes to do any cube. That's it. 1 of each, 2 of each, product in the middle. Bam, 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 bam. Okay. Say again? The funny thing about the big dude, it's never factorable, and it will always have complex zeros. Always. There's only one real zero for something like this, a sum or a difference of cubes. So what is my only vertical asymptote? -2. How can I tell real quick this has only complex solutions in the quadratic formula? What is under the square root? Not under the whole thing. What's in the square root? -b plus or minus square root of b squared minus 4ac. b squared minus 4 times a times c. Isn't that going to be negative? And that's going to be in the square root, so I know there's no real solutions. So not only can you never factor the big dude, it will also never have real zeros. It's a really good thing to just kind of know, right? Don't waste your time on it. So every equal only has one vertical asymptote. It's only one real place where the bottom is 0. Does it have a horizontal asymptote? No. What kind of asymptote does it have? Slam poetry. No. Slant. And again, I gave this away earlier. How do you figure out the slant asymptote? What do you have to do? Long division. Yeah, lock it. So if I do long division, what do I put in here? How many x cubes are there? 0. How many x squares are there? 0. How many x's are there? -2. And how many numbers? What numbers are 0? Shit. I need some placeholders, right? I really want that to make sense. When I write the number 1007, do I do this? Is that 1007? No, I put frickin' zeros and say no hundreds, no tens. So when I do this, none of these, none of these, none of, I need zeros, just like I need for numbers, because all variables are numbers. So x cubed times what is x to the 4th? X times x cubed is x to the 4th. X times 8 is 8x. Change the signs. So those cancel, there's none, there's negative 10x. And how do I know I'm done? This degree is bigger than that. Same way I know I'm done when I long divide. Numbers, right? So this would be minus 10x over x cubed plus 8. When x gets really big, this goes to 0. Yes? When x gets really big, doesn't the bottom overwhelm the top? So when x gets really big, this function looks like this. And let's do it. put this in here. Y equals, what was it, x to the 4 plus 2x divided by x cubed plus 8. If I zoom way out, doesn't it look like a straight line? You guys see that? Looks like a straight line. When x gets really big, it looks like a straight line. In the middle, it does weird shit, right? Because what's happening right here? What did we say our vertical asymptote was? Yeah, so let me put that in there. X equal -2. Bam! There's the line for the vertical asymptote, right? And if I put in there y equals x, bam! When x gets big, whatever the function is doing, it has to start to look like y equals x. That's what this means. That's what any asymptote means. It's got to start to look like this when x gets really big. So real quick, what I wanted to do, and I forgot halfway through this, if I made this an x to the 5th, can you guys see how when I divide, I would get x squared? Right? So if I make this x to the 5th, look what happens. I'm going to delete this. If I zoom out, what's it look like? Looks like a parabola, right? It looks like x squared, doesn't it? If I zoom way out, it looks like a parabola. Okay, well, okay. So whatever the result of long division is, that tells me this piece goes to 0, and this piece tells me what it must start to look like when I let it get really big, negative, and positive. Like any asymptote, that's what they mean. Okay. Anything else, guys? This is all up to you. I do have a couple of things I want to do, but yes?
When you find the x-intercepts, do you factor the top and like see what that is too?
Yeah, you gotta look at the top.
Alright,
Yeah.
so the top's the x-intercepts too.
Not 2,
No, but
that's
like-
the only place they come from.
Oh, the x-intercepts don't come from the bottom?
Definitely not. Okay. Why, what are things, what do we, hello. What do x-intercepts do? Okay, that's a weird way to say it. Why do we call things x-intercepts? Because they do what? They actually hit the x-axis, correct? What's gotta be the output if I hit the x-axis? What's the output?
Yeah.
And we all know that we make y0 to find the x-intercept, right? So the function has to be 0 at a certain input for that input to be an x-intercept. So if I have something and I factor the top and bottom, and I'm glad you're asking this, Nick, because a lot of people make this mistake. Let's say I factor the top and the bottom and I get this. What does 7 do to that function? The input of 7. What does it do?
Makes it 0.
No, it doesn't. Makes what 0?
Bottom.
The bottom. So what's 7 do to the function? What happens when you divide by 0? Undefined. What are the only 2 numbers that make the output 0? Therefore, the only 2 x-intercepts. What makes the top 0? What makes it 0? 2 and -5. -3 and 7 make it undefined. What are -3 and 7? X equal -3, x equal 7 is the location of what? Vertical asymptotes. Right? Because where do vertical asymptotes come from? They come from the x values I'm not allowed to use. If the bottom's 0, I can't use those. If the top is 0, that makes the function 0, those are x-intercepts. Does that make sense?
Yeah.
Because I know your brain sees this, I totally get it. Your brain sees it and you're like, it's just like S2, that's -3, what do you want from me? But you gotta think about what that would do to the function. Okay. All right, so let me ask my questions. Let me see, where did I put these? All right. So let's say I'm given this here. That's right. Yes. What's the list of possible rational zeros? One, two, three, six. Okay. Let me just cut to the chase. Let's divide this by 2. Right? What does this mean? What is this? All right, I'll come back to this. So divided by 2. Of course, I put here 1, 2, negative 5, negative 6. So help me out. What do I do? 1, 2. Add, multiply. Add, multiply, add. What does that mean? It works. What does that mean? What does that mean? So yeah, well, how do I factor this then? This, what do I know so far? This equals what? No? Yes, this is the 0, right? So if something works, it came from this because that's the 0 of this. What's this? Yeah, what would it start as cubed, right? I divided by x minus 2, so I'm going to have squared left. That's x squared plus 4x plus 3. Do I have to synthetically divide by more numbers to finish factoring this? No, I don't. Right? The minute you get down to a squared, you don't have to do synthetic. You just write it and then factor it. Or, all right, we'll get to another or. So what do I get? I get x minus 2. How do you factor this? X plus 3. X plus 1. So what are the zeros?
2, negative 3, negative 1.
You, right? So if it's asking for zeros, you better list them, right? So the zeros are 2, negative 3, negative 1. You can do it, Jeff. All right. So, what about this one here?
Yeah.
What do we got? Signs, what are they? Plus and minus, okay. Made some problems up earlier. Possible zeros here would be plus or minus 1, 2, 5, 10, 11, right? That's beautiful. Why are these so easy? Because the first number is 1, so I don't have to divide by anything, yes? To get my list of possible rational zeros. When I make that list, so this list, are those the only zeros that could possibly happen? Is it possible to get a 0 that's not in that list?
No.
Yes, it is. It just has to be like square root of 7. What is this the list of? It's the list of possible rational roots. I don't want to sit there and think about all the possible irrational roots. Holy shit. That list would be huge. Stay with me now. Come on. You can do it. You can do it. So somebody, pick a number. Well, should it be nice? I'll be nice. Let's do 2. So do that real quick for me. Say again? Oh, okay, sure. But go ahead and do it. You guys done? I'll catch up to you. So bring the 1 down. 2 times 1, 2. Add, multiply, add, multiply, add. Say again? I can't hear what you're saying, but how does this, what is this? X minus 2. And what's this? Is this factorable?
No.
How can you tell so quickly? Because it's gotta be numbers that multiply to be 5 and add to be -8, no numbers like that. So what's the only way to continue with this and figure out what all the zeros are? Huh? Quadratic formula, yes, quadratic formula. So you don't have to do synthetic forever, because you might get to a point where nothing works because the answer is not rational. So when we make this list, it's all the possible rational roots. The irrational roots, I don't freaking know. It was just when you hit them. So that's why, especially when you get to squared, when you get to x squared, stop doing synthetic. Either it's factorable, or it needs quadratic formula. Either way, it's easier than trying to guess at the number for synthetic, right? Does that make any sense? So I've just noticed some stuff in the very few homeworks that I've gotten so far that had me a little worried. Yes?
Wait, so how would you do the quadratic formula on that?
Oh, I mean, you just do quadratic formula. What's the negative b? What's b?
Oh, 3.
A is 1, b is -3,
okay.
c is 5. Right, it's just normal quadratic. There's nothing new about it. Yeah. So 1 0 is 2, and the other 2 zeros are going to be at least irrational, if not complex. Right? Is that right? You guys see that? So again, synthetic, we don't suddenly go, oh, we're not factoring anymore, we're just doing synthetic. No, we're doing both. Synthetic is just a new tool. When I have something, there ain't no way in hell I can factor this. Would grouping work? No. So synthetic lets us do the first step, and then I'm like, oh, cool, now I got this. I can factor it, or I could do quadratic formula. Okay. So the only time we need synthetic is if the thing I'm working with is unfactorable. Or if it's, I can't do quadratic formula. The minute I get there, I don't need synthetic anymore. Okay, maybe. So even if you haven't done the practice test, if you're looking at it, are there any that you're not sure how to do them? Yes? Which one, sorry? 10. Oh, okay. I like it. Real quick. Let's kind of build our way up to 10. How would I rewrite? Is there a way I can rewrite? I can break that up. Is there a way I can break that apart? How could I do it? Log base 7 x plus, yes, because again, this is the power of a product or same base. They each have a base of 7. What do I do with the powers? When I multiply things with like bases, I add the powers. That's the way to remember that property. Every property of logarithms is the same as the property of powers. Why does that make sense? Because logs are powers, right? Don't forget that. Real quick, what's log base 7 of 49? 2. Why? Because 2 is the power 7 needs to become 49. The answer to every log is a power. So how should logarithms act? The same way powers do. So when I multiply two things, I add the powers. All right, so we're building up to that thing. So what about this? What if I had log base 11 of x squared over x plus 1? How do I break that up? If multiplying means add logs, what do you think dividing means? Holy shit, right? It's a beautiful analogy. And again, what do I do with powers? When I divide things with like bases, subtract the powers, right? So this will be the power on this minus the power on this. Does anyone remember what I could do on this guy? What can happen with that? I can bring it down and multiply it. When I raise something with a power to a power, what do I do with powers? I multiply the powers. Put that in parentheses. Right? And it's just easier to think. If the inside is being raised to a power in a log, it can come out front. So now I think we're ready for that. There's a lot more going on. There's a little bit more going on. Can anybody tell me the fact that logarithms care about powers, which piece of that is written in a bad form? Everybody's got a power except something that's not written in power form.
Square root.
Square root, yeah. And so, one of the first things I should do, what is that, log base 6? One of the first things I have to do, how do you rewrite the square root of y? That'd be y to the 1/2, because square roots cut things in half. What is down there?
Z cubed.
All right, so the first thing is I got stuff divided by stuff, correct? So how can I rewrite that?
W squared. Minus.
Minus
Log 6. Times Z to the third.
log 6 of z cubed. I like it. What can I do with this? Don't I have w squared times y to the 1/2? How can I break that up? Yeah, log 6w squared plus log 6 y to the 1/2. And then I have minus log 6 z cubed. And what's the last thing I can do with each piece? The power can just come down. 2 log 6w plus 1/2 log 6y minus log 6z. So that's kind of taking a logarithm and breaking it up into parts. And of course, so we have to be able to break it up, and then we have to be able to put it back together, right? That's sort of like number 9 is putting them together, number 10 is breaking them apart. So in mathematics, we have to be able to go both ways.
Can you do, 8D?
8D? Yeah, all right. See if you guys remember. That is really difficult to just look at and know what the answer is. It just is. So if you don't know what the answer is, what can I call it in algebra? X. Okay. We've done problems like this. So then how can I rewrite this? 16 to the x is 1/8. Now, 16 and 1/8, are they both based on the same base? Like, are they both based on the same number? Yes. What number is that? 2. Can you tell me 8 to what power is 16? No. So 16 is not based on 8. 16 is based on 2, right? What is 16? 2 to the 4th. Now, real quick, just stay with me. That first step, we know that 16 to the x is 1/8, and we know that's how I rewrite it. 16 is 2 to the 4th, so wherever I see 16 in the universe, I can put 2 to the 4th instead, because that's what 16 is. When am I going to do it? When it's useful. All right, what's 8? 2 to the 3rd, so what's 1/8? 2 to the -3. What do I do here? Multiply, of course, right? I have x 2 to the 4th, so I have 4x2s. And then 2 to the -3. And what must be true about these two in order for this to be equal? Those two have to equal each other, right? This is saying 2 to something equals 2 to something else. Well, no, in order for that to be true, these have to be the same. Let that make sense, right? If I said 2 to 7 equals 2 to the x, well, then x is 7, because anything else I put there, it's not going to be the same as 2 to the 7th. They have to be equal to each other. And then I just solve for x. Bam! -3/4. Now, to give some of you guys a way to kind of circumvent this. 16, what power do I raise it to make it 2? Or think about like, what root do I take of 16 to make it 2? I take the what root? 4th root. So that's 1/4. How many 2's make 8? 3. And how do I flip it? -3/4. Kabam! So if you don't understand what I just did, you always are able to do this. But you can also think of it like that. 4 parts of 16 is 2. 3 of them make 8. So -3 1/4 make 1/8. So -3/4. Now again, do you have to be able to do it the way I just said? No, you got this way. Look, I got -3/4 this way. I don't care which way you do it. Maybe. Yes, sorry.
Try 8C.
Was there any other questions on this one before I? Okay, 8C. Oh. So. And you guys tell me, if I ask you a question like this, how are this and this related? Can anyone tell me that? Inverses of each other. Kabam. They're inverses of each other. Right? You guys with me? So, for example, what's 3 squared? Holy shit. Right? So, when I put a 2 into 3 to the x, I get 9. What's log base 3 of 9? 2. Log doesn't mean divide. We already have a division symbol, right? Log means power. You guys with me? So look, what was the input here? 2. What was the output here? 2. What was the output here? 9. What was the input here? 9. They're inverses of each other. Whatever one does, the other one will undo it. So if I had log base 7 of 7 cubed, these kill each other. So the answer is 3. Or 7 to what power is 7 to the 3rd? 3, right? So they will kill each other. What about 8 to the log base 8 of x? These kill each other, so the answer is x. So what is the base when I just put a log, like on part C?
1.
Can't be 1, that doesn't make any sense. Yes, so when I don't have a base, just like when I put a square root symbol without a number, it's 2. Why do we do that? Because it's the most commonly used root. So we live in California. Did you guys know that? What do we get in California that it didn't get back in Virginia? Earthquakes, right? How do you measure the strength of an earthquake? Sure, the magnitude of it, but do you guys know the R scale, the Richter scale? So that's based on log base 10. The Richter scale is based on log base 10. Decibels. Have you guys ever heard of decibels? Log base 10. I don't know why we would use base 10 the most. It might be because our number system is based on 10. So just like with a square root, I really want space. We don't put a 2. We just know it's a 2. It's the most used one. So why would I put a 2? We're just going to say when you see that, we know it's a second root. When you see a log without a base, it's understood to be base 10. Most often use log. Say again? It would. What's in the way though? The 3's in the freaking way. They want to kill each other. But the 3's in between them going, come on guys. Let's calm down. But what can I do with the 3 to get it out of the way? Put it up top. Then what do these do? Kill each other. So what's the answer? 4 cubed, 64. So a base to a power and log base that of something they want to kill each other. They are inverse functions. The same way cube rooting a cube cancels it, right? Same exact way. They want to kill each other. So if there's anything in the way, get it out of the way and then let these guys, let them kill each other. I know that's very good. So cancel each other. If you don't like my very violent mathematics, they will cancel each other to get stuff out of the way. Okay. I like it. Yes. 9C, okay. So 9C is basically the opposite of that earlier problem we did. Three log WA. So in this problem, I kind of want to combine everything into a single logarithm. 1/3 log WM. What is it? It's 2 log WX. For some reason, capitalized, yeah, sure. Okay. So do you see how these logs, don't they want to subtract? These 2 logs want to subtract. What would that become? If I had log minus log, I can make that log of the quotient, right? That's the rule. But there's something in the way. I don't have any rule that tells me what 3 logs minus 1/3 of a log does. So 3 and 1/3 are in the way again. Well, how do I get them out of the way?
Just draw it up.
Take it up top. So remember, that's sort of like the last step we did in the earlier problem, was the first step we do here, when we're trying to undo that. We're trying to combine them back into a single logarithm. Now what can I do? Log of this minus log of that becomes log of... No, definitely not. When you subtract powers, when you were doing what? You subtract powers when you are dividing. So now I have log stuff plus log stuff. Say again? No, you can combine these, right? So I'm adding 2 powers. When do I add 2 powers? When the things were multiplied. Let me show you. Right? When I have this, when log of this plus log of this is log of the product, right? Because log of a product becomes the sum of 2 logs. Watch this shortcut. What's the only thing in this list that's negative? Right here. Only thing in this list that's negative is this guy, right? Where did he end up? Because it's in negative power. Do you understand? Aren't logs powers? Yeah. So if I see a negative log, that's going to be on the bottom. Any positive logs are going to be on the top. It's beautiful. If you let it be. Okay. So let me show you an example. Here, you guys. Let's do a concrete example of the powers, of the rules of logs. Help me out. What's log base 2 of 8? What do you think when you see that? Log is a power, so you think, what power does 2 need to become 8? Because 2 is the base. So it needs a power of 3. What's log base 2 of 4? 2, right? All right, so what is log base 2 of 32? 32 is 2 times 16, right? Which is 2 times 2 times 8, which is 2 times 2 times 2 times 4, which is 2 times 2 times 2 times 2. It's 5 2s. Are you guys with me? So isn't this 5? 3 plus 2 equals 5. So log base 2 of 8 plus log base 2 of 4 equals log base 2 of 8 times 4. Because when I multiply things with like bases, I add the powers. Logs are powers. So that's a concrete example of log base 2 of 8 plus log base 2 of 4 is log base 2 of 8 times 4. Right, so the sum of the 2 logs becomes the log of the product. Same with the difference becoming a division, right? So if I see log base W of M plus log base W of A, what would that become? Yeah, log base W of Ma. Okay. So these are things you have to memorize. I'm desperately trying to give you a framework to help you memorize these things. Logs are powers, so their properties are the same as the properties of powers. When I multiply two things with the same base, I add the powers. Bam. When I divide, I subtract the powers. Bam. Right? Okay, maybe. So like part A will be nice, right? What do you do with part A? Yeah, so we log base 3 of 15 divided by 5. Log base 3 of 3 is, log base 3 of 3 is, because what power does 3 need on it to become 3? 1. In fact, what is log base anything of that thing? 1, because that's the first power. So log base 11 of 11 is 1. Log base pi of pi is 1. Right? What's log base anything of 1? 0. Because what do you raise something to make it 1? 0. Okay. What's log base anything of 1 over that thing? What do you raise b to make it become 1 over b? -1. Negative means flip. So what does that mean? Watch this real quick. What's log base 3 of 9? That's a nice, easy one, right? What's log base 3 of 9? So you did that earlier. 2. So what's log base 3 of 1/9? -2, because 2 makes it 9, negative makes it 1/9. It's almost too nice to believe. So if I see log base 8 of 1 over 64, I think 8 squared is 64, and then to flip it, bam, I kind of build it. I build what I need, right? So if I see some kind of fractional thing inside, it's most likely a negative power, so that's why it flips. And watch this. What's log base 1/2 of 1/4? Oh, Jeff, you math teacher, you evil person. Again, what are you thinking? What do you do to 1/2 to make it become 1/4? What power do you need? 2. That's it. Well, if you square a half, isn't that a half times a half? What's a half times a half? 1/4. Don't say 1. That'll make me cry. Okay. Yes. Do it again. Graph 5b. Oh, okay. So for a log function, so the problem is, let's make it the same. Log base log, that's +1 minus, okay. So we have to know what this looks like. Because what are the transformations up here? Left 1. Down 1. I can't do these unless I know what the base function looks like. And we know what this looks like. Where's there an asymptote? No, not this. This. What 0? What do you mean? Which axis is the asymptote?
Y.
Y-axis, okay. Right, and then if I put a 5 in, what do I get? 1. If I put a 1 in, what's log base 5 of 1? 0. If I put a 1/5 in, what's log base 5 of 1/5? -1. So here is the base function. So every log has that shape, and just like with the exponential where I have 3 anchor points, I can have 3 anchor points with the log. Why do I want to give myself anchor points? Because now I know what to do with each point. What do I do with each point? Left 1, so let's pick this point, right? So it's got to go left 1, and then down 1. This point, left 1, down 1. This point, left 1, down 1. Where does the asymptote go?
1.
Like you said earlier, yeah, it's going to go back, it's going to go left 1, right? So now there's an asymptote here, and now you can see how that's matching up. Weehaw! Just like anything, just like any function, the transformations are always the same. It's just the shape that changes. And then I move it around. Yes?
Wait, how did you find the base functions one more time? The base point?
Just gave myself some anchor points. So like, all right, so real quick. For example, if I gave you an absolute value equation, wouldn't the base function look like 0, 0, 1, 1, negative 1, 1? That would be the base, right? I have 3 anchor points. So here I got 3 anchor points. They are 5, 1, 1, 0, right? And 1/5, negative 1. Gotta keep myself straight.
So
So I got my
if it was log base 3, it would be 3, 1.
3, 1, 1, 0, 1/3, negative 1. It's crazy, right? So basically, log base b of x has b1, 1, 0, 1 over b, negative. You always have those 3 points, and then you can just move those 3 points around.
Alright.
Okay. A lot. Okay. And real quick. Do you guys remember how to find this guy's domain? What's got to be true about this? Has to be greater than 0, so x has to be greater than -1. Is that what the graph says? Yes, x is greater than -1, right? You gotta check what you did.
What happens when you do log base 5 and -1?
What's up? Sorry? No. So my inputs are these, right? Those are my outputs. So what's log base 5 of 1/5?
-1.
Yeah. So the output is -1. At 1/5, the output was -1. Yeah. Maybe. So this is what I said when we first learned transforms. We're going to learn other functions. We're going to learn trig functions, for example. Are you guys excited about that?
No.
Somebody is. Okay, good. Trig functions are awesome, right? There's oscillatory little dudes. They're kind of freaking awesome. We're going to learn their shapes, and then we're going to move them around. It's crazy. We're going to squeeze them. They'll be like springs. We squeeze them, and they go, ee! Or we pull them, and they go, wow. Right? So all the same transforms do all the same things, no matter what the shape of the thing is I'm looking at. Does that make sense? No matter what function I'm looking at. If I see an x plus 1 inside, it's going to move left 1. Whatever the hell it looks like, it's going to move left 1. Maybe. So now we know exponentials, right? We know logarithms, right? So we can add those to our list of basic functions that we know the shape of. Okay, maybe. Let me go ahead and give you guys the answer key, so you have some time to prepare. And let me just say this again. If you didn't try the practice test at all, don't look at this and go, yep. I would have done that, right? It's not going to help you. Oh, I think I wanna do one of these in class, yeah. I think did we? We did B. I don't wanna do two. Do one behind. We did 5B, let's do 5A. I just decided I didn't want to try to squeeze it in there. What are the transforms in 5A? Left 2, down 3. So you almost always do the up or down last, just to be safe. So the base function is what? What's the base function? I'm gonna take out those, what do I get? 2 to the x. I take that plus 2 away, then minus 3 away, I get this. So what does my base function look like? It's gonna have an asymptote where?
0.
Well,
At x
y equals 0, or the x-axis, right? What is 2 to the 0?
1.
Yeah, 2 to the 0 is 1. 2 to the first power is 2. 2 to the negative 1 power is? I think I heard it. 1/2, I love it. So here's my base function. And then you just move the damn thing around, right? You gave yourself some anchor points. So how do I move those? I take one, I move it left 2, 1, 2, down 3, 1, 2, 3. Take this one, left 2, 1, 2, down 3, 1, 2, 3. Take this one, this is gonna be a little weird. Take this one, left 2, 1, 2, down 3, 1, 2, 3, halfway. Where does the asymptote go?
The next whole number.
Well, it goes down 3, doesn't it? Left and right doesn't do shit to an infinitely long thing. If I move an infinitely long thing left and right, it doesn't care. It still moves down 3. So I understand what you meant, but yeah. So then this will be, here's the answer. Shabam! Same way we did that one, just maybe a little bit easier. We're a little more certain about the exponential shape than we are about the logarithmic shape. Isn't that exactly what we were doing before with like absolute value and parabolas? You're moving them around. Same thing, just have a new shape. But we move them around in exactly the same way. What if I put a negative here? What would that do? It would flip it over, right? Okay, so it's reflections still work the same way. Is there anything else I didn't do? I think that was the only one I didn't do. Okay, cool. Okay. Yes.
Can you do AB? One with the E.
Oh, all right. So I promised myself I would never write natural log a different way, but what is the base of a natural log? Say again?
10.
No, that's log. Base of log is 10. Natural log, ln, where'd it go? There it is. Yeah, what's the base of it? E. So what is it the inverse of? Natural log is the inverse of e to a power. So what do these do to each other? They're inverses, so they cancel. So what's the answer? 5. That's awesome. So I need you to start seeing. If I ask you, why is this question easy as shit? Why is that such an easy question? I said simplify that. It's easy, right? What happens? These cancel. So what's left? This. That's the answer, right? You guys with me? So this should be equally easy. That's log base 10, that's 10 to the power, they kill each other, done. Bam! Any inverse functions that are acting on each other, they annihilate, they cancel each other. We know that's how they work. We're just not so used to logarithms yet. I understand that, but it's just the inverse of an exponential, so they will kill each other. So if I had pi to the log base pi of e, what's that? Yes, because pi to a power and log base pi cancel each other. The answer is e. Okay. So just to show you on that part A, for example, I'm going to ask you log base 3 of 81. Can't you think about what's 81? Break it down. 9 times 9, keep going. So isn't it 3 to the 4th? So isn't this log base 3 of 3 to the 4th? Well, what do log base 3 and 3 to a power do? Cancels. The answer is 4. Now that's kind of silly because right here you knew the answer was 4 because the question is saying how many 3's multiply 81. Well, now I know it's 4, but there's another way to see you get 4 a different kind of way by using the fact that they're inverses of each other. So if I ask you what's log base 7 of 343, what do you think you would do first? Cry? No. What did we do on this one? Did we start to break it up? What do you want to try to divide? What do you hope this will divide into? Do you hope that 6 goes into it? No. What do you hope goes into it? 7, right? So what's 343 divided by 7? My hand calculator doesn't exist yet. Say again? Holy shit. So 343 is 7 times 49. And what's 49? So what's log base 7 of 343? How many 7s does it take? 3. The answer is 3. Done. So if I ask you some question like this, the question is asking you how many 7s multiply to, okay, start dividing this thing by 7. Start breaking it up. You know, if I give you log base 2 of 8, you know that's 3. You don't have to do that, but you could. But if I give you one that's not immediately obvious, now you know how to attack it, right? Am I going to give you one like this? Sure, probably. Okay. So logarithm is basically tearing something apart, right? That's why it's a lot like roots. It's very much like roots. If I say, what's the cube root of something, you break it up into 3 parts, correct? Logarithms are very similar. They're not the same thing. They're definitely not the same thing, but they're very similar. So you can ask questions from the quiz, you can ask questions from homework, from the practice test. And just to let you know, on the actual test, I will probably be a little more nice with this, I'll probably tell you, figure out f of 3 is and f of negative, whatever it is, the ones that will help you out the most. I will give it to you in steps. I'm not just going to say, graph this, and you have to remember all the steps. I'm going to tell you, find the intercepts, find the vertical asymptotes, find the horizontal asymptotes, right? So you do all the steps, and then you just have to put them all together in a graph. You guys remember Descartes' rule of signs? No? So if I gave you yeah, buddy. So Descartes' rule of signs. If you just leave it alone, what's the basic thing Descartes asked you to look at? Change in signs. So many times does the sign change? So what does that mean?
There's 4 positives.
There can be 4 or 2
complex.
or 0 positive real roots. Why do they go down by 2? Because if they're not real, they must be complex. And complex always shows up in pairs because of quadratic formula, plus or minus. If that makes sense. How do I investigate the negative real roots? What do I look at? F of negative x, right? I try to show you a shortcut. If I raise a negative number to an even power, doesn't the negative just cancel, go away? I really want this to make sense. All the even power shit is going to stay the same sign, because when I put a negative x in, the power is going to kill it. It's going to stay the same sign. All the odd power stuff is going to stay negative. Those will change sign. So that changes sign, that stays the same. That changes sign, that stays the same. And of course 7 don't give a shit what you do in x, it's just 7, right? So how many sign changes are there here? 1. So what does that mean? There can be only 1 negative real root. In fact, we know there's 1. There's 1 negative real root. So if I make my list of stuff, I'm going to try the negatives, because look, the positives, there could be none of them that work. Now, to be honest, I might use the positives because there's a chance that 4 of them work. Are you guys with me? But I know that there's definitely 1 negative root. Do you guys understand? That's what Descartes does. And again, when it is useful, it is really useful. So most of the time, Descartes doesn't do much for me. This really didn't help me. It could be negative, could be positive. If I made a problem that all the signs were positive, how many positive roots could there be? None. The sign would never change. So then I know I could eliminate all the positives. My list gets cut in half immediately. So when Descartes works, we're like, thank you, Descartes, nice. He doesn't work very often, right? I can still tell like this, but does this really help me? Not really. Because I know there's 1, there could be 4, there could be none, there could be no positive. Thanks, Descartes, Okay. I'm still going to ask you this. And what about bounds? How do I tell if it's an upper bound? If I divide by a positive number, and the answer is all positive, that number is an upper bound. If I divide by a negative number, and the answer is all alternate signs, that number is a lower bound. What does that mean? If it's an upper bound, I can just cross off all the shit bigger than that. If it's a lower bound, I can just cross off all the stuff that's lower than that. And that's why I told you, if I have this big-ass list of stuff, I normally start with some number in the middle. There's a pretty good chance it's going to be some kind of a bound, right? You guys kind of with me? So I'm gonna do my best to give you enough hints so that you're not having to try every number in this big ass list of numbers. Holy shit, right? Just like, I'm pretty sure on the quiz, I did. Now, of course, if you don't interpret Descartes' rule of signs correctly, and you don't know what lower bound means, then my hints didn't do you any good. But, my hints, you have to know what they mean to be able to use them, right? So I'm going to try to make a function where the bounds and Descartes' rule does help you. So if you know what they mean, you got less work to do, right? Okay. Which one, number 2 or 3, has a slant asymptote? Number 3, because it's got a higher degree on top. What is the horizontal asymptote for number 2? 0, because the degree on top is lower than the bottom. I love it. So you'll have a horizontal asymptote on the x-axis in that case.
Can you say that again?
So since number 2, the degree on the top is lower than the degree on the bottom, in the long run, it's got to get smaller, smaller, smaller. So you're having a horizontal asymptote at 0. So the x-axis will be your horizontal asymptote. So it'll do like that, maybe, and like this. Well, what would I change here so the horizontal asymptote was 2? What would I change? If I just make the x squared on the top, right? Then the powers are the same, and then the horizontal asymptote is the coefficients divided, right? Is that cool? So those are your 3 possibilities. Top, lower, 0. Top and bottom, same degree. Ratio of the coefficients. Top, bigger than the bottom, goes to infinity, but it follows a slant asymptote. Those are the 3 possibilities. Where have I written those down for you? On 2 handouts that I gave you. 2 handouts, spell that out for you. Okay. So if I were you, I don't know if anybody does this, as I'm doing my homework, I would have all my handouts sitting around me, right? So look at a problem and go, shit, oh, that one helped. No. Can you do that on the test? Oh, hell no. You want to get it in your head, so you want to kind of that's one reason why I give those handouts, is so you can have them sit next to you as you do your homework. You got these reference things. Okay. Anything else? If there's no other questions, you guys can head out, but if you have questions, let me know. Everybody got their quiz back? Anybody come in after I... 5 through 6-5. The test is on 5 through 6-5. Yeah.
You could what's the time?
Say again?
I didn't get it.
Oh.
I came in like 5 minutes late.
Drew, right?
Yes.
All right, guys. See you tomorrow. If you have more questions, just let me know. Yeah. Yeah. Oh, so the whole point was to show it's a lower bound. So what is it about this that tells you it's a lower bound? You need to tell me, since this, then it's a lower bound, right? Yes, you gotta say that. Otherwise, I don't know if you understand how to interpret the results. Does that make sense?
Yeah.
So somebody could not understand it, they just do this, but they don't know what it means. So you gotta tell me why, yeah.
And also on this I know that I should have put like the last class. This quiz I didn't understand.
Oh, yeah, so you can just pull the 4 in so you can make it, it'll be 4x minus 3 then, it won't be a fraction. But that's not why you lost those because of these.
Yeah, okay.
That's just, you could put it in there if you wanted to and not have a fraction.
Okay. And on the graph,
Yeah. So I just need to know what it does up here, because there's a thing here.
I just have to like draw it.
Yeah, you have to figure out what it looks like there, right? And there's a horizontal asymptote at 3, so you know it's, so I really want this to make sense. There's no x-intercept here, right? So you know where the x-intercepts are. So it pretty much has to look like this. So you just have to plug in like 5. If you plug in 5, you can see where it is, and then you can kind of fill it in. Yeah.
Here.
Sure.
Okay, so back to this question, I'm so sorry. So I plugged in, you said calculate the minimum?
Yes.
Okay.
So you, let me see, let me catch up to you.
Because I plugged in my
Alright, here's what
calculator
they
and that's what
told
it
you.
gave me, so.
Solve for H. And if you plug that in here, don't lose the X. See how there's an X there?
Oh.
So one of your X's cancels, yeah.
That's so awkward. Okay.
It's okay. Yes.
Okay, so for this one, like if I try to do F3, would I plug it into this one or the bottom? Like
You have to plug it into the whole thing.
to the whole thing.
F is this whole thing. So if you make F of 3, every X becomes a 3.
Okay, but I would plug it into the factor.
Or you
When
could
I
either,
factor
yeah,
it,
you
right?
could either plug it into the original or the factored form. I
Okay.
normally use the factored form because then I
It's
can do
much
each piece,
easier?
it's easier.
Okay, okay, thank
But
you.
they're
So
both
all
the
of
same.
it.
Yeah,
Okay,
yeah.
thank you.
You're welcome. Oh yeah, you're coming back. You can go over there.